As humanity stands on the brink of becoming an interplanetary species, the road to establishing a permanent presence on Mars requires us to solve some of the most complex challenges ever faced in human history. One of the primary hurdles we must overcome is the development of reliable greenhouses that will enable sustainable agriculture on the red planet. While the harsh environment of Mars presents many obstacles, one of the less obvious yet critically important challenges is Mars's low gravity, a force that is only about 38% of what we experience on Earth. Low gravity might seem like a trivial factor compared to the harsh cold, cosmic radiation, or lack of breathable air, but it plays a crucial role in every aspect of life and construction on Mars. For greenhouses, which are not just structures but life-sustaining systems, the effects of reduced gravity ripple through the entire design process, influencing how we build, grow, and sustain the crops that will one day feed the first Martian settlers. The task before us is monumental, but humanity has always risen to challenges that seemed insurmountable, and the vision of a thriving Martian future is well within our grasp. Mars and the influence of low gravity on structures. Mars is a world of contrasts. Though it shares similarities with Earth, from its rotation period to the presence of polar ice caps, the lower gravity of Mars introduces unique engineering challenges. Gravity on Mars is only about 38% that of Earth, meaning that any object on Mars weighs just over 1/3 of what it would on Earth. At first glance, this might seem like a benefit. Materials will weigh less, so building on Mars should theoretically be easier. However, the reduced gravity affects more than just weight. It alters how materials behave, how structures bear loads, and how plants grow within greenhouses. The structural integrity of greenhouses is critically influenced by this lower gravity. Greenhouses on Mars must be airtight, strong, and capable of protecting crops from extreme temperatures, dust storms, and harmful cosmic radiation. Designing these greenhouses under low-gravity conditions requires rethinking how traditional load-bearing principles apply. On Earth, gravity helps keep buildings grounded and secure. In Mars's weaker gravitational field, buildings are not pulled down with as much force, which means wind forces from dust storms, for example, could have a greater impact on the stability of the structure. Therefore, the materials used to construct these greenhouses must be lightweight, yet exceptionally strong. New advances in materials science, such as graphene composites and carbon nanotube-reinforced polymers, will be essential in ensuring that these structures can withstand the external pressures of Mars while maintaining structural integrity under weaker gravitational forces. Additionally, the foundations of greenhouses may need to be anchored deeper into the Martian soil, utilizing geotechnical engineering solutions tailored to Mars' unique environment to ensure that the structures do not shift or collapse under the planet's weaker gravitational pull. Designing greenhouses for growth in low gravity. While the structural concerns of building in low gravity are substantial, the more exciting and transformative aspect is how plants will respond to growing in a low-gravity environment. On Earth, gravity plays an integral role in plant growth, influencing everything from the direction roots grow, gravitropism, to how water and nutrients move through the plant's vascular system. In low gravity, plants will face entirely new challenges, and our greenhouse designs must account for these changes to ensure the long-term success of Martian agriculture. Water and nutrient delivery systems will need to be adapted to function properly in the lower gravity environment. On Earth, gravity naturally helps pull water down through the soil and into the roots of plants. Without this force, hydroponic and aeroponic systems become even more essential, as they rely less on gravity and more on controlled, precise delivery of water and nutrients. In fact, the reduced gravity might even provide an advantage for hydroponic farming, allowing water to spread more evenly around the roots and reduce the risk of oversaturation or underwatering. Beyond water delivery, low gravity will also impact how plants grow and support themselves. Many plants rely on the force of gravity to determine the direction in which they grow, with roots extending downward and stems growing upward toward the light. On Mars, in low gravity, these natural processes will be altered. Plants may grow in unpredictable directions, or they might struggle to grow tall and sturdy without the same gravitational force they experience on Earth. To address this, Martian greenhouses may need to implement artificial gravity environments, such as rotating sections within the greenhouse to simulate Earth-like gravity. Alternatively, trellis systems and supports could be installed to guide plant growth and ensure that they grow upright and strong despite the reduced gravity. Furthermore, low gravity also affects plant physiology on a cellular level. Studies conducted in space, such as those aboard the International Space Station, have shown that plants in low-gravity environments exhibit changes in cell structure, gene expression, and photosynthesis efficiency. On Mars, plants may need to be genetically modified or bred specifically for the Martian environment, ensuring they can thrive despite the unique challenges posed by lower gravity. Innovative solutions for construction and maintenance. With the low gravity on Mars affecting both the design and operation of greenhouses, innovation in construction techniques is key to overcoming these challenges. Traditional construction methods used on Earth may not be feasible on Mars, especially when it comes to assembling large, complex structures in such a hostile environment. One promising solution lies in the use of autonomous robotic systems for building and maintaining greenhouses. Robotics and automation will be essential for the success of any large-scale construction project on Mars. These robots can operate in conditions that are unsafe or impractical for human workers, and their precision will ensure that structures are built to the exact specifications required to withstand low gravity and Mars's environmental extremes. Robotics will also play a key role in the ongoing maintenance of greenhouses, allowing them to operate efficiently with minimal human intervention, freeing up astronauts for other essential tasks. Another innovative approach involves the use of in situ resource utilization, ISRU, which means utilizing the materials available on Mars to build the greenhouses. Martian soil, known as regolith, can be transformed into construction materials using advanced 3D printing technologies. This reduces the need to transport building materials from Earth, which is both costly and logistically challenging. By printing parts of the greenhouse directly on Mars, we can construct lightweight but sturdy structures optimized for low gravity, leveraging the natural resources of Mars to support our efforts. The role of greenhouses in Mars colonization. Greenhouses are far more than simple structures designed to grow plants. They are the lifeline of any future Martian colony, representing the very essence of human sustainability on Mars. Without successful agricultural systems, no long-term human settlement can thrive. The ability to grow food, produce oxygen, and recycle water within these greenhouses is fundamental to ensuring that astronauts and settlers can live independently of Earth. As humanity looks to build permanent settlements on Mars, these greenhouses will form the backbone of self-sufficient communities. By mastering agriculture in low gravity, we will not only solve the problem of food security on Mars, but also create a blueprint for establishing self-sustaining colonies on other celestial bodies. This means the technologies developed for Mars farming could one day be adapted for the Moon, Europa, or even exoplanets beyond our solar system. The prospect of growing fresh produce on Mars, using greenhouses tailored to the unique conditions of the planet, is not just a technical achievement. It is a symbol of hope for the future of human civilization. The day when the first crops are harvested on Martian soil will be remembered as a defining moment in the history of our species, proving that we can adapt, innovate, and thrive even in the most extreme environments. A vision for the future, humanity flourishing on Mars. The vision of life on Mars is no longer confined to the realm of science fiction. With each technological breakthrough, we inch closer to establishing permanent human settlements on the Red Planet. Greenhouses, specially designed to overcome the challenges of low gravity, will play a crucial role in this endeavor. They will provide not only food and oxygen, but also a sense of home, a connection to Earth through the plants we grow and the ecosystems we create. In the near future, we can envision large-scale farming complexes on Mars, supported by networks of greenhouses that utilize cutting-edge gravity adaptation technologies. These greenhouses will be fully integrated into Martian cities, where humans and plants coexist in an environment that supports life. The ability to grow crops on Mars will not just solve practical problems, but also inspire generations of explorers, scientists, and visionaries who will see Mars as a second home for humanity. Low gravity will no longer be an obstacle, but an opportunity. An opportunity to innovate, to push the boundaries of what is possible, and to transform Mars from a barren wasteland into a thriving world. Humanity has always overcome the challenges before it, and Mars will be no exception. The future of human life on Mars is filled with promise and potential, and the development of greenhouses adapted to low gravity is a crucial step toward making this future a reality. Mars awaits. The challenge of building greenhouses on Mars in a low-gravity environment is daunting, but it is far from insurmountable. Through innovation in material science, robotics, hydroponics, and gravity-adaptive technologies, we will create thriving agricultural systems that will sustain human life on Mars. This is not just about survival. It is about thriving on a new world, creating communities, and expanding the frontier of human civilization. The future of Mars agriculture is bright. The dream of seeing Martian fields full of crops, growing under the Martian sky, is no longer a distant vision. It is a future within our reach, and with every step forward, we get closer to realizing this bold and optimistic vision of human exploration and survival beyond Earth. Mars awaits, and we are ready to flourish among the stars.